Okay, today we're going to go over polar arc length, which is, I admit, not on the AP test, but I figured we might as well go over it anyways. It's pretty simple to learn and memorize. In fact, the equation is very close to the other parametric equations. The other arc length equations, those being parametric and rectangular. So let's get into it. This is the equation. The length of a polar curve from position A to B, or theta A to B, I should say, because A and B are represented by theta, is equal to the integral from A to B of root r squared plus dr over d theta squared in respect to theta. So, of course, r over here is essentially the function. It can also be represented by f of theta, and dr d theta is just the derivative of f of theta, or just the derivative of r. So that's it for the background info. Okay, so this is practice problem 1. We're told to find the length of the curve of r equals 3 cosine 2 theta from theta equals 0 to theta over 6 to theta equals pi over 6, sorry. So just to remind you, the equation for arc length, at least in terms of polar curves, is the integral from a to b of r squared plus dr d theta squared in respect to theta. So from here we can just plug in our values. However, we don't yet know dr d theta. So we're going to find the value of the derivative of r, which is going to be the derivative of 3 cosine 2 theta, and that's equal to negative 6 sine 2 theta. That is if we employ the chain rule. So we already have all we need for the equations, and so we can just plug everything in. So the a, which we're going to allow arc length to be represented as, is equal to 0, the integral from 0 to pi over 6, square root of 3 cosine 2 theta squared plus negative 6 sine 2 theta squared d theta. So, of course, we could technically do this by hand, I suppose, maybe. However, I don't really want to spend 30 minutes on this question. And so I just plugged this into my calculator, and I was able to find that it was equal to 2.115, and that is the value of the arc length. Okay, so this question, practice problem 2, tells us to find the length of the curve of r equals 2 sine theta when a particle representing r's position is outside of sort of the area bounded by L equals 1. It's terribly worded, I admit, so I'll just draw what's going on here. So let's let this circle here represent 2 sine theta. And let's let this circle here represent L equals 1. What I'm trying to do is trying to find the value of the arc length given here. And so what we first need to do is we need to set the two equations equal to one another. So let's say that L equals R. From here we can say that 2 sine theta is equal to 1, which means that sine theta is equal to 1/2. And therefore, theta equals both pi over 6 and 5 pi over 6. So this one is, at least the values of the theta are quite simple. And so now from here, we can just write our equation, or at least we can begin to write our equations. We don't yet have every term we need. So let's let r represent the arc length from the integral of pi over 6 to 5 pi over 6 of the square root of r squared, which we already have. You can say that's equal to 2 sine squared theta plus dr d theta squared in respect to d theta. However, we don't have dr d theta. However, we do know that it's just equal to the derivative of r, which is 2 sine theta. And so the derivative of 2 sine theta, and therefore the value of dr d theta, is equal to 2 cosine theta. And from here, we already have everything we need. We can just plug this in here in place of drd theta squared. And again, I suppose maybe you could do this if you wanted to by hand. However, I'm too lazy to do that. And I just plug this into a calculator once again, and it is equal to 4.189. And that is the value of this arc length. That is the end of this video as well. If you have any suggestions, please put them in the comments below. Thank you.